Good morning to dear students. Today I am going to discuss about heat affected zone and soldering and brazing and different welding defects. Now first I will explain heat affected zone. So it is a zone or area near to the weld bead in between the base metal and the weld bead. So that zone is called the heat affected zone. This heat affected zone is not completely melted, but it is affected by heat. It is affected metallurgically. Due to that, its microstructure changes and it leads its mechanical properties are affected. The strength of the heat affected zone is less than the strength of the base material, the component to be welded, and it's because of this heat affected zone, so that the brittleness of the component and the weld zone is increases. Next topic is welding defects. So we have several welding defects. It includes slug inclusion, undercut defect, porosity defect, incomplete fusion, hard cracking, cold cracking, and lamellar tearing. So I will explain one by one. First of all, I will explain slug inclusions defect. If the slug particles are trapped inside the weld bead, the resulting defect is called the slug inclusions defect, and it can be occurred because of the slug particles are not moves up to the weld bead, and if it is moves up to the weld bead, it can be grinded or by wire brushing can be removed easily. But because of that is improper weld design, some cases slug particles are trapped, so it leads slug inclusions defect. Next is undercut defect, and because of high amperage and low welding speed, wrong electrode angle and long arc length and high welding speed, there is a groove is formed and that is not filled. So the resulting defect is called the undercut defect, and it can be prevented by decreasing the amount of heat and by increasing the weld speed. This undercut defect can be prevented. Next is porosity. So while performing welding, atmospheric gases are trapped inside the weld bead. So the defect is called the porosity defect, and this defect can be rectified by providing the inert gas environment like tungsten inert gas welding, metal inert gas welding. The inert gas is provided and it protects the weld bead from the entering of the atmospheric gases. It can be so completely the porosity defect can be prevented. Next is incomplete fusion. So due to low amperage and high weld speed, short arc gap, and this incomplete fusion defect is occurred. That means the weld bead is not completely melted. The defect is called the incomplete fusion, and this can be prevented by increasing the amount of the heat supplied and by decreasing the weld speed, so this defect can be rectified. See lamellar tearing. Lamellar tearing, it is a clear visible separation line between the base metal and the heat affected zone, and this defect is caused by the presence of elongated inclusions such as manganese and ferrous in the base metal. and this can be rectified by choosing the proper electrode or by reducing the residual stresses in the transverse direction. So next defect is weld cracks. So we have the two types of cracks, that is hot crack and cold crack. So hot crack is occurred at the high temperature at the starting of the welding. The cold crack is occurred at the room temperature after completely solidification of the weld bit. And a hot crack can be prevented by the workpiece welded, parts to be welded should be preheated before to start the weld. And cold crack can be rectified by, so after completion of the welding, immediately it is subjected to suitable heat treatment process, we can rectify the cold crack defect. Next topic is soldering. So soldering and brazing and welding is the permanent joining process. In soldering, brazing and welding, the heat is required and the filler meat is also required. But welding is suitable for similar materials only. And amount of heat required is more compared to soldering and brazing. And soldering is the process of joining two or more dissimilar materials by the application of heat and filler material. But the filler material melting point temperature is below 450 degrees centigrade and below the melting point temperature of the base metal. It is called as soldering. In soldering, the workpiece metal is not heated to a molten state. Only the filler material is heated and melted and is applied by capillary action. The filler material used in soldering is called as the solder. The commonly used filler material is tin and lead. And we have the different types of the solders by varying the proportions of the tin and lead. So that is soft solder 40% of the tin, 60% of the lead is used, and medium solder 50%, and the electrician solder it is 60-40, and the plumber solder it is 70-30% of the lead and tin is used. And commonly flux material in case of soldering is zinc chloride, hydrochloric acid and magnesium chloride. And usually it is used to, so that it join the wires to the electronic PCB boards. It is used in electronic industry. And now we will discuss about soldering methods. We have the three types of soldering methods. One is soldering iron and dip soldering and wave soldering. So usual method is soldering iron. In soldering iron, it is a tool. So it gets the heat from the electrical source just by inserting the plug, and after certain time it is heated. That heat is used to build the filler material, and the filler material is supplied by means of a capillary action. That method is called the soldering iron method. And next one is dip soldering. In dip soldering, so already there is a molten solder pool is prepared. Into the molten solder pool there are pre-assembled, that is components are dipped for certain time and it is removed and it allows to solidify. That is called the dip soldering. There is next is wave soldering. So in wave soldering, parts which are to be soldered are not completely dipped into the molten solder pool, but a wave is generated in the tank so that the solder comes up and makes the necessary joint. That is called the wave soldering. And we have several advantages for soldering. Basically it is made for dissimilar materials, that is not possible by the welding, but it is especially for lower temperature, less temperature applications, and the thermal distortion is less compared to welding. There is a less chance of damage, and the speed of the joining is more compared to welding, and no need of skilled person is required to perform welding. And limitations are the strength of the solder joint is less than the brazed as well as the welded joint. And if it is used for higher temperature applications, it is not preferable. This is about welding. Next is brazing. Brazing is similar to the soldering, except its filler melting point temperature it must be above the 450 degrees centigrade, and at the same time it is below the melting point temperature of the base material. And in case of brazing also, the filler material is supplied by means of a capillary reaction. So usual filler material in case of brazing is copper alloys, and flux material is borax and boric acid. And we have the different types of the brazings based on the heat source, that is torch brazing, furnace brazing, deep brazing, induction brazing, resistance brazing. In torch brazing, the source of heat is acts as certain flame is supplied by means of a torch, that is called the torch brazing. And furnace brazing, so the furnace heat is used to raise the temperature of the filler material. By using that heat, the filler material is melted and it is supplied to the narrow zones of the components to be joined. The furnace may be operated by oil or gas furnace or electrical furnace, except deep brazing. In deep brazing, same as the solder dip method. In this method, there is a molten pool of, so that is brazing filler material is already prepared. Into that, pre-assembled components to be brazed is submerged and dipped, and it permitted to enter the filler material into the narrow zone. Then it is removed and it allows to solidify further will with the joint. So that is called the deep brazing. Induction brazing. There is an induction coil is the heat source for to get the heat. There is a high frequency AC weld. So the heat will produce due to induction phenomena. Resistance brazing, a process that uses electrical resistance of workpiece, the high frequency current induced into the same as a source of heat generation. These are the different types of the brazing we have. Once again I am going to revise, so that we have discussed about heat affected zone. The heat affected zone is the zone in between the base metal and the weld bead. It is affected metallurgically, and its microstructure and its mechanical properties are altered, and the strength of the heat affected zone is less than the strength of the weld bead. That's why we have to reduce the heat affected zone by choosing the proper welding process, like laser beam welding, electron beam welding process. So we can focus the flame and we can reduce the area of the weld can be reduced, and that is flame is focused on this limited area, and we can reduce the heat affected zone compared to gas welding as well as the arc welding. So in between, comparison between arc welding and gas welding is the heat affected zone of gas welding is more than the arc welding. This is about heat affected zone. Next is welding defects. So we have the several welding defects. Suppose porosity is because of trapping of the atmospheric gases, porosity defect occurred. We can rectify it by providing the proper inert gas. Next is slug inclusion. The slug particles are trapped inside. Slug inclusion defect is occurred. So we have to design the weld bead in such a way to prevent the formation of trapping of the slug inclusions inside. And that undercut, there is some groove is formed, and incomplete fusion. Some portion of the weld bead is not completely melted. These two defects can be rectified by such taking the proper amperage, optimum amperage and optimum weld speed. These two defects can be rectified. And next is hot crack can be rectified by preheating. Cold crack can be rectified by this suitable heat treatment process. Next is lamellar tearing. So this is clear visible lines between the heat affected zone and the weld bead. So that should be prevented by choosing the proper electrode material. And also there is weld spatter is there because of arc blow. Some globules of the weld pool is separated from the electrode material and deposited into the weld bead. It is called as the weld spatter defect. So we can rectify the weld spatter defect by choosing the proper electrode material. So that is called as the weld spatter defect. Next we have discussed soldering and brazing. Soldering and brazing is a similar type of metal joining process. So it is both are used for two different materials, to weld dissimilar materials. Soldering is, so it's a melting point temperature. The filler metal is below 450 degrees centigrade. It is called as soldering. And filler metal melting point temperature, if it is above 450 degrees centigrade, it is called as the brazing. So the strength of the brazier joint is higher than this soldering joint. Soldering is for electronic industry and brazing is for pipe joints, and wherever leak proof joints are required, brazing is preferable.